Good day everyone, I am Mr. Cuestas, and together with Mr. Badilla, Ms. Udalbe, and Ms. Cuestas, we will be discussing some problem sets from topics 1 to 4 on our lecture class. For problems number 1 and 2, I will be the one who will discuss the process as well as its answer. For problem number 1, caffeine, which has the molar mass of 194.2 grams per mole, is a stimulant found in coffee, tea, many soft drinks, and chocolate. Elemental analysis of caffeine shows 49.47 mass percent of carbon, 5.19 mass percent of hydrogen, 28.86 mass percent of nitrogen, and 16.48 mass percent of oxygen. What is the molecular formula of caffeine? Before we will proceed on the solution, we have to determine first its given so that it will be easy for us to solve the problem. What was given from our problem is our molar mass, which is 194.2 grams per mole, 4.47 mass percent of carbon, 5.19 mass percent of hydrogen, 28.86 mass percent of nitrogen, and 16.48 mass percent of oxygen. And according to our problem, we were asked about the molecular formula of caffeine. In order to solve the molecular formula of a certain compound, we have to determine first its empirical formula, since empirical formula is the simpler version of representing compound. So to solve for the empirical formula, we will assume a 100-gram sample of each element. So here from our 49.47 mass percent of carbon, we will have a 49.47 grams of carbon. Next, we will multiply our 49.47 grams of carbon to its grams-mole ratio. We know that on every mole of carbon, there would be 12 grams present in accordance to the periodic table. Also, class, take note that the values may vary from each periodic table. Like some periodic table states that carbon has 12.01 grams or 12.002 grams, but as long as the values are close, we don't have to worry since we're solving for ratios here. Therefore, it will be just rounded off to the nearest whole number. So simplifying this equation, 49.47 grams of carbon times 1 mole carbon divided by 12 grams of carbon is equal to 4.123 moles of mole carbon. Next, on our hydrogen, same process, we will just multiply our 5.19 grams of hydrogen to its gram-mole ratio. And we know that in every mole of hydrogen, there are 1.01 grams of hydrogen. Some periodic table may be 1.009 or 1.008, but again, it won't matter. Simplifying this equation, we will get 5.14 mole of hydrogen. Next, on our nitrogen, by doing the same process, we will get 2.061 mole nitrogen. And lastly, on our oxygen, simplifying this equation, we will get 1.03 mole of oxygen. After these, we will divide each values we have solved to the least value. In our case, our least value is 1.03 mole from our oxygen. So dividing every value to 1.03 mole, we will get this. As you can see, we're just going to divide each value to 1.03. So for our carbon, 4.123 mole divided by 1.03 mole, we will get 4.001. And since we're dealing with ratios here, we will round off our value to its nearest whole number, which in this case, it will be 4. Next, for our hydrogen, simplifying the equation, we will get 4.99, which will then be rounded off to 5. For nitrogen, by doing the same process, we will have 2.001 as a result, which will be rounded off to 2. Lastly, for our oxygen, 1.03 mole divided by itself, we'll get 1. Now, we have the results. So what we're going to do next is to equate the values to its corresponding element. So our carbon has 4 moles, hydrogen has 5 moles, nitrogen has 2 moles, and oxygen has 1 mole. So our empirical formula will be this: C4H5N2O. After getting the empirical formula, we have to compare the empirical formula mass to the given molar mass. And in order to determine its empirical formula mass, we will just have to get the molar mass of our empirical formula. So, we know that carbon has 12 grams on every mole. And since we have 4 moles of carbon according to our empirical formula, we'll just multiply 12 grams to 4. So by multiplying 12 grams to 4, we will have 48 grams per mole. Same also to the following process. We know that hydrogen has 1.01 grams on each mole, and since we have 5 moles of hydrogen according to our empirical formula, we'll just multiply 1.01 grams to 5. With that, we will get 5.05 grams per mole. And by doing the same process to our nitrogen, we will get 28.00 grams per mole. And lastly, to our oxygen, by simplifying the equation, we will get 16.00 grams per mole. After this, we will add all the values of what we have obtained in order to get the molar mass of our empirical formula. So by adding these values, we will get 97.05 grams per mole as our empirical formula mass. Now, since we already got the value of our empirical formula mass, we can now compare our empirical formula mass to the given molar mass. We know that our molar mass, based on our given, we have 994.2 grams per mole. And according to what we have solved earlier, we have 97.05 grams per mole as our empirical formula mass. Here we will just input our values to our equation, so we will now have 194.2 grams per mole divided by 97.05 grams per mole. By simplifying this, we will get 2.001, which will then be rounded off to the nearest whole number, since again we're dealing with ratios here. After that we will multiply this value to our empirical formula in order to get the molecular formula. So since we have 2 based on what we have solved, we will just multiply that to our empirical formula. Thus, we will get this as a result. With that, we now have our molecular formulas, which is C8H10 and 4O2.